So if we're looking at chemical equations, they have to be balanced properly. Law of conservation of mass. I can't create anything new, so whatever I start with, I'm going to end with. Evidence, we'll talk a little bit about that towards the end. We're going to do a big lab where we get to see that. Chemical equations, how do we draw them, and why do they need to be balanced? We'll talk about the why, and then we'll actually balance some of them. And then there's your vocab. So, a chemical reaction, the process by which one or more substances are rearranged. And that rearranged is a very important word. It's not taken away, nothing is added, things are just rearranged to form something different, and that's called a chemical reaction. Right now you have multiple chemical reactions happening in your body. You are breathing, chemical reaction. Just after lunch, you're digesting, chemical reaction. All of the processes that build proteins and things like that are all chemical reactions. Evidence that we're going to look for in the lab is a change in temperature without human involvement. If I heat a pot of water, that's a physical change. I'm adding heat to it. If I take two liquids that are room temperature and I pour them together and they get hot on their own, that's a chemical change. So, change in temperature without human interaction, or change in color without human interaction. If I paint my house red, that's a physical change. I am taking red paint and I'm putting it on my house. If I take my yellow banana, no, let's go back a step. I buy a banana and it's green, what color will it turn to? Did I do anything to make it turn yellow? No. Once it's yellow, it'll eventually turn brown. Did I paint it brown? So your banana changing color is a chemical change, which if you eat bananas at all, a green banana, a normal banana, and a brown banana do not taste the same because there is a chemical change that's happening. Odor, a production of an odor. So quite honestly, your body odor is part of a chemical process. Cows, humans, whatever, passing gas is part of a chemical process. Or just something all of a sudden, like burning, the smell of something burning is evidence of a chemical reaction. And then we're going to look for bubbles. So when bubbles appear, and appearance of a solid. Precipitate, if you remember that word at all, possibly from your freshman year. We're going to be looking for precipitates, which are solids. So those are all things that show a chemical reaction has occurred. And then this table is in your notes, and it's also in your book. You are responsible for knowing everything that's on this table, which there's not a ton to it. So when we write something, chemists use what's called equations to show what's in the chemical reaction. Reactants are what we start with. Products are what are formed. And the table shows how we use them. So for example, if I have hydrogen and oxygen make water. So the plus sign separates some things that are different. So if I have hydrogen and oxygen, that's two separate things. If I have H2O2, that's peroxide, that's one thing by itself. So the plus sign separates things. The arrow is your divider that shows here's my product, or here's my reactants, and here's my product. So it separates your reactants from your products. You can use the term produces or yields water. Sometimes you'll see something that has an arrow going both ways. And that means that it's a reversible reaction, and it can go both ways, and we'll talk more about that later. Hydrogen is a gas. G stands for gas. Oxygen is a gas. Water can be a gas. It can be a solid, or it can be a liquid, depending on what state it is in. And then the last one, AQ, means that it's been put in water. So for example, I can have NaCl solid, which is what? Sodium chloride. It's what you put on your French fries. It's a solid. However, I can also have NaCl AQ, which means I've done what with that salt? I put it in water, and now I have a salt water solution. So AQ means that, you're welcome, means that whatever I have is a mixture, and it's put into water and makes a solution. So that pretty much summarizes what's on the table. In word equations, so if I write out the whole word equations are going to simply read what's there. So aluminum and bromine react to produce aluminum bromide. So word equation, you're going to read it. That should make sense. Skeleton equations, we're going to use the symbols. We're going to write things out, but a skeleton equation is not balanced. So it's an unbalanced equation. It's just the framework. And then both word and skeleton equations lack the information of the balancing part, of how many atoms are there, how it's properly balanced. So we are going to use formulas in our chemical equation. So it's a statement that uses formulas to show the identity, what's in it, what am I using, and the amounts. So I have an aluminum atom, I have 2 bromine. Bromine is in group 7, so it's always diatomic. And then I have an aluminum bromide, so it shows all the different parts to it. And I get to see, physically see, what's in that equation that I'm working with. When we balance equations, we show how we make it equal, because, like I said, I can't create something new. I can rearrange things, so this aluminum was by itself, and now it bonds with 3 bromine, so I can rearrange them. But if I start with 2 aluminum, I need to end with 2 aluminum. If I start with 2, 4, 6 atoms of bromine, I need to end with 6 atoms of bromine. Whatever I start with, I have to always end with. So we use a coefficient, which is the big number in front. We use a coefficient to balance the equation and show the lowest whole number ratio of reactants and products. So once we have the skeleton equation made, I can use subscripts when I'm writing my skeleton equation. But once I start balancing, I can only use coefficients in front of my other reactants and products. That we'll look at later. I'll do problems. And then this is in your book, Law of Conservation of Mass. And as juniors, I kind of, Law of Conservation of anything means it can't be created or destroyed. So mass cannot be created or destroyed. So if I have 2 aluminum on my reactant side, I need 2 aluminum on my product side. They have to be the same. So balancing equations is the way that we show that. So this is just kind of a flow chart that shows the steps that you go through. And the last page is your review. So evidence, that's an important slide. Make sure you know the things that we look for when we do a chemical change. Make sure you know that table that shows all the different signs, and then balancing equations, we'll simply practice how to do that. And that's all of section 1.